Exponential derivatives. Chain rule, a quick and easy method. So here we have a function y, and within that function you have a, which resembles a letter, which resembles a number, to the power of x. When you derive the function y, you get ln a multiplied by a to the power of x. This is the exact same as writing 10, well, not the exact same, but because a resembles a number, so you could write 10, you could write 7, 14, 32, 727, whatever you want. But when you have a number to the power of x and you wish to derive it, you keep the number to the power of x, but you multiply it by ln of that number. I hope that makes sense. Hope you can piece it together. But we'll do a few more examples. So the quick and easy method is quick and easy. I don't write out notations. I don't write out any workings. I just do it all in my head, and I show you how I do it. It makes things much quicker, much more efficient. So let's start with an example. 3 to the power of x to the power of 3 plus 2. So here we have our function x to the power of 3 plus 2. Within our function, 3 to the power of x to the power of 3 plus 2. So we do the chain rule. Chain rule states that you derive the outside and leave the inside the same, and then you multiply that by the derivative of the inside. So if we derive the outside, it'd be ln 3 multiplied by 3 to the power of x to the power of 3 plus 2. How did I get this? This is just the deriving the outside, 3 to the power of that. It's because in this, the way you do it, when you have to the power of a function or the power of x, you treat it as a to the x, because they're the same. You follow the same steps. There's a to the x, which is a number to the power of x. Here you have 3 to the power of a function that includes x. So you have ln a, we've done ln 3, because that's the number, and then we multiply it by a to the power of x. In this case, we multiplied it again by 3 to the power of x to the power of 3 plus 2. See, we leave this the same, and then we just multiply it by the natural logarithm of the number. But we still have to multiply it by the derivative of the inside, when that would be 3x squared, because the derivative of x cubed plus 2 is 3x squared. And that's it. And for another example, let's say we have ln 7x, 7 to the power of x. We'll have y equals ln, and within ln you have 7 to the power of x. So we find the derivative of the outside and multiply it by the derivative of the inside. Derivative of the outside, 1 over 7 to the power of x, because when you derive ln, it just becomes 1 over whatever's in the brackets of the ln. Now, we multiply that by the derivative of the inside. 7 to the power of x, that becomes ln 7 multiplied by 7 to the power of x. Again, when we derive the inside, we're just focusing on the 7 to the power of x. We keep the 7x 7 to the power of x, and we multiply it by ln of the 7. And that's the first derivative. Well, we can simplify this. We cancel out the, because when you multiply 7 to the power of x on 7 to the power of x, you just get 1. So the actual final piece is just ln 7. That's the first derivative of this here. Now for another example, let's say y equals cot or cotangent sine 4 to the power of x. So we have a function within a function within a function within a function. We derive that. Let's derive the outside first while keeping the inside the same. So derivative of cot negative CSC or cosec squared. We'll leave the inside the same. Then we focus on the second lot, which is sine 4x. We find the derivative of the outside function, which would be cosine 4x, because we keep the inside the same. And then we multiply that, and we'll do it down here because we can't fit it. Multiply that by the derivative of the innermost function, which is ln 4 multiplied by 4 to the power of x. Because we keep the 4x the same and we multiply it by ln of the 4. We can make this look a little neater by bringing the negative 4x ln 4 CSC squared sine 4x multiplied by cosine 4x, 4 to the power of x. And that there is the first derivative of that up here. Only do this if you're comfortable with doing derivatives at a faster pace. I'm still doing them fairly slow because I'm explaining it, but hopefully you are understanding. So let's have 10. Within that we have 10 to the power of ln of x. So we have our first, the outermost function. We derive that first, which becomes sec squared. We'll leave the inside the same. And then we derive the second innermost function, which is 10 to the power of ln. We derive the outside, so that would be ln 10 multiplied by 10 to the power of ln x. And then we multiply that again by the derivative of the innermost function. Derivative of ln is just 1 over, or derivative of ln of x is just 1 over x. I have a video on natural logarithms and derivatives if you want to check that out, but that's it really. And so we put this all together, it just comes out looking like 10 ln 10 x multiplied by ln of 10 sec squared 10 ln of x all over x. That's your first derivative. Thanks for watching. I hope this helped.